Latency and buffers in a SoundGrid system. Any digital audio system is comprised of different sets of buffers that deliver the audio from one point to another. These buffers introduce latency to the audio signal path. An example of such a buffer would be analog to digital conversion. This process involves a buffer that is used to create the digital signal, and this process introduces latency. Another example is plugin processing. Some plugins reserve a small buffer for pre-process calculations. This buffer introduces latency when running audio through the plugin. Types of buffers. The SoundGrid protocol uses three main buffers to deliver and process audio over the Ethernet network. The SoundGrid server buffer. This determines the number of samples used to complete the round trip from the I/O device to the SoundGrid server and back to the I/O. This buffer is set in the SoundGrid host application's interface. The network driver buffer. This determines the amount of audio samples used to deliver the audio from the ACO core audio driver to the SoundGrid network. This buffer is also set in the SoundGrid host application's interface. The ACO core audio buffer. This determines the amount of audio samples used to deliver audio from the DAW to the I/O device via the ACO core audio driver. This buffer is set in your DAW's settings. The SoundGrid network stamps all frames it generates on the network and assigns a timestamp to each frame. This lets us trace each frame on the network to know if there are any dropouts or out-of-sync issues, and measure your total latency using the same process. SoundGrid is a sample-accurate system. It can alert a user if there is a drop of any frames or if any frames are missed, indicating there is an issue that needs your attention. When a SoundGrid audio interface sends a frame, it stamps that frame with a timestamp. It then sends it across the SoundGrid network. When the frame is sent to the DSP server, that is where the audio is processed. The frame is then sent back to the network and then back to the I/O. If this process happens under the SoundGrid server buffer time, it will be completed successfully. If for some reason things take longer, the result will be an audio dropout. Switches and distances between devices. Planning the distances between devices on a SoundGrid network is an essential part of being able to plan what type of switch will be needed. The distances for cabling listed on this page are there to help you make sure you plan and configure your setup accordingly. The main switch is the switch that is closest to the SoundGrid I/O that is defined as the system clock master. The SoundGrid DSP server should be connected to this switch, not to other daisy-chained switches. The maximum distance we support for a network cable between your main switch and the SoundGrid DSP server is 32.8 feet, or 10 meters. If you have cable runs that exceed these suggested distances, frames may not arrive on time and will potentially result in dropouts. For distances longer than the above, you can use an alternative to the standard 1 gigabit network switch. View this web page to see switch configurations that can extend your distance up to 984 feet or 300 meters.